Hello. Hi, everybody. My name's Tom. And thanks for coming along to my talk, which is called Putting It All Together. Let's give it a roll. Get the slides over. Just gonna do some furious alt tabbing now. Oh, as I said, it's my talk, Putting It All Together. I'm talk about a few things because this title is really vague and doesn't really suggest what I'm going to actually talk about, which if you're ever writing a talk in the future, I can advise you do not do because it makes your life very difficult. So what I am going to talk about is I'm going to talk a bit about event style architectures, different types of them, the type we've ended up building, and kind of a little bit about how you choose between them maybe. Then I'm going to talk a little bit about core.spec, which I'm quite interested to see how that bit turns out, given that everyone has talked a bit about core.spec. So there's some slides to my section a few hours ago, which will be interesting when I get to them if I forget that I've done that. One of the things I think is interesting about this talk, or one of the reasons why I wanted to give this talk, was because I work for MastodonC, and we really believe in open source. We use loads of open source, but we develop everything in open source. So everything I'm going to talk to you about, all the pieces of the software I'm going to mention, the platform that we're developing that forms the context of this talk, is open source, and you can go and check it out. Poke holes in it, please do. But I thought this was quite different because it means these things aren't sort of abstract. Obviously there will be some abstracts and some examples drawn from these things, but all the code is actually there for people to go and see. So you can always feel free to ask us questions about it, or do whatever you want with it. If you want to borrow a piece of it, that is fine too. So yeah, I'm not just going to tell you about it. I can show it. So what is this platform? It's got a nice vague sounding name. It's called Kixi. This is a big project for Mastodon. It's consuming quite a lot of our resources. And Kixi encompasses both the software that they're developing, but also the infrastructure. So the infrastructure we have defined and is version controlled everything else using a custom DSL we've developed called Terraboot, which is like a nice way of producing Terraform definitions. And that defines for us an AWS infrastructure. And the point of this is that because we are envisaging deploying many instances of the Kixi platform, if you like. And that definition sets up a load of boxes of VPC, starts Mesos on them. So we're running all of this on a small Mesos cluster via Marathon orchestration. And all of that is nicely replicated for how many times we're going to do, and it's always the same. I'd love to talk about that more. That isn't actually what I'm going to talk about. What I'm going to talk more about is the software that we're running on this platform. So that side of things it's a data sharing platform. And it's primarily aimed at local governments or that sort of type of institution. Now, these organizations have real problems sourcing data just internally and finding data and organizing data. This is the big problem. So this isn't one of the, some of you may have heard of the open data projects that are going on around the world these days. Moda in New York, and there's other ones in Milan and stuff. These are cities are trying to open the data about themselves out. Our project is about making sure that the institution can look at the data itself, find data that it owns for itself. Because when you find out how they do it at the moment, it is hilariously bad. Probably shouldn't say that. Anyway, I did. But the thing we're adding on top of these things as well is schema verified sources, so that we want people to be able to trust that a data file has what it says it has inside it. So a big part of this project is about verifying data, and also, not quite yet, but soon we'll have user-generated schemas for stuff, which is also going to be fun. But you know what? That isn't actually what I'm here to talk about either. Because a talk like this is not really interesting about really about what the software is for, the features that it's delivering. What we're generally more interested in actually is how. How does it go about doing these things? So this is the platform as it stands now in its infancy. We have four main components. Got user interface, because at the end of the day, this system is for humans, and humans like user interfaces, particularly the kinds of humans that work in local government. Then there's a gateway, and this is a backend for the front end, a BFF, and this intermediates requests between the UI and the backend. So this is where the queries come to, authorization happens like this. Then there's Heimdall, which is actually our user data repository. So in Heimdall is where we have user accounts and user group associations. So everything in the system, all the permissions in this system is activity-based, which if I've got time, I'll mention a little bit more about later. And all those activities are assigned to groups. So certain groups are allowed to do certain things with files, with data. And Heimdall is where those users are attached to groups. The data store, as you could probably guessed, is where the data is stored. But not really, because actually all the real data is stored in S3, and data store is more of a metadata storage microservice. And actually all the metadata, goes into S3, for search. And data store sort of manages those activities and the group assignments, and controls the authorization of when a user tries to download something, say update the metadata for a file. So this is all wonderful and looks fantastic, I'm sure. But of course, if you just throw your services out into space like this, not very much can happen because there's nothing joining them together. And these things can't do anything if they're not joined together. So what you need is a communication pattern in order to bring this stuff to life. We are big fans of queues. I cannot stress how much of a fan of queues I am. That is how exciting I am. Queues are fantastic. They allow you to separate what happens from when it happens. They are incredibly flexible, and they really drive decoupling into your design harder than anything else. People will walk around saying single responsibility principle until they're blue in the face, but unless you've really got a queue in there, then you don't know if someone's going to start cheating. So queues are other business. We like queues, and we don't even really think about it anymore. It's always a queue. But a queue doesn't really say enough, it's just a queue. What really powers these things and where the real benefit comes from is when you start talking about what you put on the queue, because queues can take anything. So what we kind of boiled down to, and what I'm going to go through now is, I'm trying to think of a sort of like a 4-stage pyramid of what you can put on a queue. And what these do as you go through each stage is add constraints on what you put on the queue. So they make it more and more difficult, if you like, and more complex to use your queue, but they give you more and more power, because the more you can rely on certain facts being true, the easier it is later on down the line to do things. So the bottom of this hierarchy are messages, because messages are, practically says nothing. It's just a thing. So message passing can be anything. You get a lot of the benefits here of your queue. You get a nice version of control where consumers can control the rate of processing. So even with messages, you've got some nice back pressure things. And you've also got that nice scalability. You can scale the consumers for a message independently, and you get that nice decomposition. But at the end of the day, a message kind of looks a bit like this. You've got your producer and your consumer, and they're talking via this green queue. But all I've said about what I put on my queue is message. So it's just like a wibbly blob. Could be anything. No one can make any assertions about message. It's just a message, at least in my definitions. Where things start to get interesting is when you step up. So you step up from here, you can step up to something called event-driven. Now, really helpfully, Martin Fowler released a blog post earlier this week, which probably quite a lot of you read, which redefined lots of the words that I am about to define, which was obviously brilliant. I've tried to match up what I'm going to say with Martin's blog so that you can draw comparisons between the two, and we'll see how well I managed to achieve that. But basically, event-driven, which I know Martin likes to sort of avoid using, use it as a catch-all term, I'm actually going to say means a bit more like this. And this is similar to Martin's event notification definition. So here we have the idea that when you do a thing, and here you see the producer is writing to the database, you produce an event afterwards to say you did it. You know, I did this thing, and that's what your events are. So now we don't have wibbly messages on our queue, we have an event. And an event is a harder word than a message, so it deserves a nice squarey outline rather than a wibbly message one. But all we have here really is I've done a thing, and then you're putting an event on the message to say you did it, and then this can be used to drive, event-driven, drive other features. So that consumer can then look at that event, and maybe you can go and look up in that database. You know, the event just sort of says, I created this ID, so the consumer can go and look in that database for that ID and do whatever it wants. Yeah, Niley, that blog. I've got all the questions up to the left of me, so I can see what you guys are saying. So hopefully I can be a bit interactive if people have anything to say. I should see it down here on my left. But yeah, so this is event-driven, which, you know, is good and might be useful for some circumstances. But this is only stage 2. We can go a lot further. We can step up to event sourcing. So now event sourcing turns things around a little bit. It changes the relationship between the updates and the events. So now, instead of doing a thing and releasing an event, what we say is that system elements should source their data from the event. Okay, so here you can see the producer is producing an event, and the consumer is consuming it and then writing it to the database. So this is, Fowler called this event carried state transfer to make it more complicated sounding. But really, I think event sourcing. So I'm sourcing my data from the event, and all data in the system can be sourced like this. And this is where you get to two very crucial ideas. Up to this point, they've not really featured, but now you've really got to be concerned with idempotency of your events. So that event, to create an entity, you should be able to run, well, must be able to run that event, process that event multiple times and still have the same outcome. You also get this idea of source of truth, which is a nice, fun phrase in event-driven systems, where now treat this log as the source of truth in your system. What is on the log is all the information. So in order for that consumer to write to that database, the information needed to write it must be in that event. And so now, really, the log, the queue, is the database in many regards. And we're going to come on to that idea in a big way now. Because when you step up from here, you can step up to CQRS. So this is command query segregation. Now, when we started out, there was quite a lot of talk about CQRS, and we were quite keen on doing CQRS. You know, we can talk about why. Well, it's a fun conversation. But what is also really fun is after a few months, you can have a really interesting conversation with colleagues about whether you actually have done it. And this makes plain that these things sound quite cast in steel. You know, they're very definite recommendations, but when you come to implement them, always there's a bit of slack built in. But anyway, how does this look different? So the key thing added to my mind, although others seem to disagree, in CQRS is you end up with your system looking a bit more like this. So now we have producers creating command events. So now we have two kinds of events, really, even though I've called the second one event unhelpfully. So now we have a command, and these should encapsulate the verbs of your system. So a command would be, well, in this case, would be create metadata, or perform transaction, say. Do this thing. Then you have a decision maker. So you have something looking for commands, and they'll be probably looking for a specific kind of command. And they decide, the person who's asking this to happen allowed to do it. Is it a valid request? Should we let it go on? Those sorts of things. Regardless, they should always produce an event afterwards, an acceptance event or a rejection event. Now, the key thing here is what CQRS says really is that event is now a post verb, so it's happened, and the mindset you have to get into when you're using this kind of system. So my command is create metadata. The event, all going well, is metadata created. Now, as soon as I write that event into this queue, the system is allowed to consider it having happened. Shouldn't the arrow between event and consumer point the opposite way? It should. Nice one. Yes, that arrow should be pointing the other way. Now what happens is, let me move my place then, Thomas. Once the event is written, the system can consider that it has happened. And anything downstream of that is basically wrong, until it consumes that event and updates itself. And this is where you really start getting into eventual consistency fun. So different parts of your system will be at different times in the log stream. And so they will have slightly different picture of what is the truth. And this can create lots of problems for you. And it's something that we definitely did struggle to control at the beginning. And it's something you've always got to come to terms with, and there's no beating this. This is just how it is. It's kind of how it always was, but this sort of throws it really into your face. And I'm going to come back around to how it does that exactly later. But the key concept is that once you've written that event, it has happened. So if you can imagine a couple of consumers here, we actually have two consumers. One of them sends the information back to the UI to say, this has happened, and another one might write it to a database. And it's perfectly fine and it's perfectly okay for the UI when it gets back that event saying it happened to state it has happened, which is interesting because it's in the queue, and the queue is our source of truth. Now, obviously, the queues we were just looking at a second ago in the core async in SQS, it was mentioned that there was like a day retention. If your queue is your source of truth, then calling it a queue really isn't a very good idea, and you need to adopt a slightly different word. And your retention needs to be forever, which is where we come to Kafka. It's something we live with and deal with every day, Dailu. I'm going to show the pain this causes later on a bit, or at least vent about it. So for our queue implementation, we use Kafka, which actually turns the queue into a log, which is subtly different. Mainly, we chose Kafka because we've got a lot of operational experience with it. Everyone's been using it for many years. We're very familiar with using it, which can't be underestimated when you're building a greenfield project like this. That having some bits that everyone's used to is very nice. If everything is brand spanking new, I dread to think what would happen. Kafka has lots of fantastic properties as well. It is a durable queue. It can be backed up nicely into S3. But all those nice features whereby you can reread the whole queue and generate new state. I'm talking about those as well in a little bit. It also lets you draw these fantastic architectural diagrams. So when those lovely requests of like, can you draw an architectural diagram, Tom? And I say, yeah, it looks like this. People think you're taking the mick, but actually this is pretty much what it is. Everything talks to Kafka, and that is it. And so everything just ends up in these nice, simple diagrams. The bit that isn't shown in this nice, simple diagram, because you've always got to leave a little bit out of a diagram, otherwise, you've given away too many of your tricks, is where the queries come from. So the queries are all driven over HTTP. We experimented with GraphQL, but we've binned that off after a little while. So we've actually just had a nice simple REST query interface now that do the querying, but this is where all state changes, all state information goes via this kind of setup. So Kafka. If you're going to use Kafka, you need a consumer. So now Kafka consumers, well, like a lot of modern systems, actually, Kafka pushes a lot of the complexity onto its consumers. So it's up to the consumer to keep track of which topics and which partitions, which parts of topics it is listening to, and its offsets that it's out, what its position is. So there's no central controller. The control is distributed into the consumers, so the consumers become fat. In recent versions, the consumer API has received a great deal of attention, which is good, because before it was really complicated, and it still is pretty complicated, actually, to the point where what we did and what I would highly recommend everybody do, and in fact what was shown yesterday in the architecture talk, is develop a reusable library for talking to Kafka across all your services. You do not want to have 3 or 4, 6, 10 different implementations of this logic in your system. It will be a nightmare. It's complicated stuff to get right. So do it once and do it right. It also gives us lots of nice properties. We have a nice, so kixi gives our services a very simple little API to talk to, where we just attach filter functions, or actually just keywords. Say I'm interested in events like this, and then we say, when you see events like this, call this function with that event. It gives us a great place to put some specs to say our events must look like this. They must have these fields in them. Commands must look like this. And it also allows us to ensure that events generated by a command have the command ID in as well. So we get all of that is handled in this library. So I think the benefits of doing this are very high. Seriously, you should do it. Because the next slide is got quite a bit of code on it, actually. Because I look at kixi, and there's a lot of faff around this, and I've trimmed a bit of this so that it could fit on one slide. But this is the kind of code you end up with when you are communicating with Kafka. So, at a glance, you can say, I don't want 6 different implementations of this, because the complexity that's occurred here now with the new simplified Kafka consumer API is that everything has been boiled down to this poll function, which you can see just at the top there under the loop. So poll, and the idea was that all you would have to do to talk to Kafka was call poll to get messages, and then off you go. Unfortunately, what they've done is they've completed poll with keep alive. So not only do you use poll to get messages out of Kafka, but you also have to use it to keep your client alive, so that the Kafka servers, brokers, don't think that your client's gone away. So if we just quickly spin through here, you'll see what I mean. So what we do here is we poll for messages. If we get some in that whenlet, then we pause our consumer. Okay. Then we process our messages. So here we've got a bit of core async code where we fire off the message into the handlers, and that does the dispatch for us by the filtering. And then what we do next is we wait, and you can see we're alternating between waiting on a result channel, which would be the response from our message handler, which would be like will be another event. We also wait on a timer, because what we need to do is, if we have a slow running process, say the event processing takes a few seconds, we need to keep calling poll to tell Kafka that we're still alive. And that's what the pause is about. So when you call pause, it means when I call poll, I don't want messages. I'm just telling you I'm alive. Don't kill me. I'm still alive. I'm going to ask for something in a minute. I'm still here. And then when we finish all our messages, we tell Kafka, right, I'm resuming now. I'm going to carry on. Next time you hear from me, I'm going to actually want something from you. Aha. I will develop this pointer. So this is where we're, so this is, so here we're polling, then we pause, then we dispatch our message, the event, to our message handler logic, and that's where that's the dispatcher. So that will do, you know, which function, have I got a function for this message, basically. And that returns a result chan. And then what we're doing here, this is alts from core async, and it basically waits on many channels. So we're waiting to hear back from our function, and we're waiting to, but we've got a timeout of a second. So what we do then is we say, if the channel that responded is a result channel, isn't the result channel, then poll, and that's the keep alive call. So you're saying we have to wait for some processing to be done before we can handle the next event. Okay. Yeah, so we are processing our events now, and our events can take a while to process because we're going to do things like breaking down data files and stuff. So in a simple example, you probably won't see this in many of their examples, which is sort of why I thought I'd highlight it, because generally they say you should take things off Kafka and put them on an internal queue. Obviously, then you lose your commit offset management. Then becomes quite complicated. So believe it or not, this is actually simpler. So what we do is we get some messages, then we pause, and what pause allows us to do is call poll, and then poll changes from getting messages to a keep alive call. So what we're doing here is every second we're reminding Kafka that we're still alive whilst we wait for something to come back on our result channel. And then when we've got it, we tell Kafka that we're going to continue now. We're ready to go. Ignore that bit. That bit is partition assignment. And then we loop back and we get some more messages. This bottom section here is our shutdown channels. So all our loops have kill channels. So what this means is that when we shut down an instance of datastore, for instance, it will process all the messages it has in memory. Then it will say, "Oh, are you turning me off?" And if not, then get some more messages. Otherwise, commit my offsets, tidy up, close the consumer, on we go. Cool. Is that good? We're happy? I'm going to carry on like you are, but I'll just say something and I'll see you down on the left. So actually that simple diagram becomes a little bit more complicated. Oh, wow. We're eating time rapidly now. It actually ends up looking a bit like this, with a nice little wedge of kixi. I'm going to might start skipping bits now. We're 6-7 minutes behind schedule. Call it spec. So I mentioned spec earlier in our kixi comms. When we started this project, the 1.9 alphas were just being released. And so we just decided we were going to stop using prismatic schema, and we'd just jump in with spec. We have adopted the crunchy on the outside, GUI on the inside methodology, which means to say that anything that comes in or leaves memory should have a spec for it. If you look in the code, you'll find out this isn't true. Like all good goals, we haven't achieved it, but it's definitely something that we'd like to be true. And one of my activities of next week is to try and make it even truer. But basically, anything that comes in, we want a spec for. Anything that leaves, we should have a spec for. So queries, events, commands, and writes to our data stores should be spec'd. One of the first things that happened when we made the move was we started looking at the conformers. And I think a lot of people, not just us, I think other people did this too, when they read conformer, they heard coercer, because hopefully people know one of the big features of prismatic schema was that you could coerce your data type. So you'd say, in this schema, I want a key, and its value I want to be an integer. But if you get a string, call this function. If it's something that is an integer, you can call this function to turn it into an integer. And that was coercement. And so what happened was we all thought, hey, conformers, they're coercers. And off we went. And it turned out to be a total disaster because of something a bit like this. This is my sort of go-to example for this, boiled down quite a bit. I'll break out the pointer again. So here we have a spec, cat. This is the cat spec, which I think from yesterday, hopefully we're all very familiar with. We're basically saying in this cat spec, we want a keyword followed by an integer. And then when we conform data to the cat, we get a map, kw from here to the keyword, int from here, and we get the integer because that's valid. But then what I've done is I've passed the result of the conform back through again. And I've called conform there, but I could have called valid or explain or any of the other things. And it says it's invalid, right? Because clearly that's invalid, right? That is not an array. Now my problem with this is that it means that you can't round trip data between the coercer in conform. And this is what made me realize that it was different from coerce. Because in coerce, you get data, you would coerce it, and what you got back might be changed, but it was still valid. Whereas here, we get data, we conform it, what we get back is no longer valid data. It no longer adheres to the specification. And this cropped up again and again when I was trying to make my conformers coercers, to the point where I actually gave up. And now we're going to break into the bit which I just made up this morning because I realized that perhaps I was wrong. So here I realized I said a lot about conformers, but I've never actually shown what a conformer looks like. So this is one of our conformers because we wrote a lot of these. This is for Boolean, which is quite simple. So this is both a predicate and a conformer for core.spec, for Clojure spec. So we say if it's a Boolean, then you're fine. If it's a string, then if it's one of these strings, it's true. And if it's one of these strings, it's false. Otherwise, it's invalid. We're not going to recognize it as a Boolean. And then we define our Boolean type as a conformer of bool, this function. And then this is an unformer, which we're just going to use identity. And you'll see what that's important in a minute. But because we messed up our bool function, we're not using the default one, then we also have to supply a generator. So when we want to use this in the generators for generative testing, we're saying you can use Boolean to generate values for this type. So, trying to remember the slides I made this morning. This is how it goes down. So now we can say we've got a type bool, we've got a cat spec b, which must be one of these, and then you can see if we conform to this spec, a little vector of the string true, what we get back is actually a Boolean true. And then you can see if we conform and unform, because we've got that identity unformer, we get back a little list. Cool, I really like it. But the trouble is, if we put in something that we don't recognize, something that's invalid, then we get an exception. And obviously, the solution to this is a little function like this, where we conform stuff. If it's invalid, then we just return it. If it's not, then we unform it. And this lets me do things like this. So a little vector with t in becomes a list of true. Is it valid? If I coerce this, is it still valid? Yeah, it's still valid. And if I do foo, then it becomes invalid, rather than a horrible exception. I literally wrote this morning, but it has got me excited to go back to looking at conformers being coercers. I asked in the Slack room whether anyone else thought it was a good idea, and everyone's ignored me. The thing you should notice there, though, is that the vectors become a list. And Alex Miller this morning said that actually there is interest in there being a cat v. So there might be a cat v coming soon. So that you could say, at the moment you say cat, and it just talks about sequences. But there might be a cat v soon, and that will allow us to say, it's got to be a vector, which will hopefully unform into a vector, and that will then make this good, and I will be happy. Oh, crumbs. Okay, right, we're going to have to really hit the afterburners now. This is something else this is, we can literally just do, sorry. This is something to really be aware of with spec. Oops. this is maybe getting old now, but you can see in this M spec, we've just got KW specified. But here, because we have a spec for int, it is used. So when you validate against mat specs, all the keys are validated, regardless of whether they're in here. Yeah, I think we saw this yesterday, but I don't think that can be said enough because it is confusing as hell. And also they're open for extension. So this is just extra stuff. This is obviously nice, and I totally agree with it. But if you misspell things like I do, this becomes annoying. But you know, your mind is very early. Perhaps you don't spell things as badly as me. Anyway, one of the other things that was talked a lot about core.spec bringing was testing. Testing. That's what we were told. It was going to do away with tests. You'd never have to write any more tests because we've got Clojure spec. Hooray! Clearly that wasn't true, and we all knew that. But anyway, we gave it a go. If you write all your specs and you fdef all your functions, that is to say you put an argument spec and a result spec on them, then what you'll think you can do is you can do this, which is instrument them. And what this does, as was shown yesterday, is enables your input and output specs. That's what you think it does, but actually it doesn't. Instrument only turns on your argument specs. It doesn't actually enable your output specs. The output specs are only used in generative testing. So that's a bit of a fun thing you find. Right, okay, here we go. So generative testing, I've got a lot of words here that I use in practice, but to be honest, the key thing about generative testing is it's great for your pure functions. Anywhere else, it's not so great. And in fact, I would go for, I would say that actually exhaustive testing has been more useful. So if your problem space isn't that big, and the one we've got in this example is the activity and the permission systems. So there's tests that want to check that given certain permissions, you can only do certain activities, and you know these things don't interfere with each other. It's better to exhaustively search that problem space than generate random lists of activities to see if you find any problems. So I would say don't underestimate the value of exhaustive testing over generative testing. And you can always move from an exhaustive test to a generative test if it becomes too slow later on, because your code will already pretty much be exactly the same. Except instead of having a generator, you'll have something like subsets, which is what I use at the moment. All our tests are pretty much integration tests. I am actually a big fan of integration tests. They get a hard time, and one of the things people say is, you know, oh, the integration tests are always really flaky. Sorry, exhaustive testing is what I've called, so say I've got a list of permissions and I want to check that each permission only allows you to do certain things. And if I combine certain permissions, they still only allow you to do those certain things. Then you can use a function called subsets that will return all the subsets of that list. And so that what that means is that the tests exhaustively check every single combination of permissions to make sure that they operate correctly. So that's exhaustive testing. So it's like generative testing, but without the randomness. Because remember, generative testing just randomly wanders around problem space, which is great, but you've got to wonder a lot to make sure you've found all the valleys and potholes. So you do have to be aware that it is just stumbling around. It's a bit more sophisticated now, but it's good to have that in your mind as how it works, I find. Integration tests, yeah, flaky. If you can't run integration tests on your staging environment because it's too flaky, then what chance have you got of having a stable production environment? Yeah, integration tests are fantastic, especially at the early stage of a project where you're plumbing things together and you're working out where the systems work. Do that. But eventual consistency does bite hard here. So if you look at our tests, there's wedges of code around weights and looking for events coming back. And generally, yeah, dealing with the fact that the system is eventually consistent. Okay, right, 40-second wrap up. Putting it all together. Eventual consistency is a total pain. This will hurt, but once you tame it, it starts to work for you. Now, probably, if you look at this project, you'll see how little it does for so much code. And the question that you ask, and I ask myself every day, is was it worth it? Was it worth doing all this to do such a small amount of features? Now, what we have is coming up is that we actually have some requirements that we know are fairly near that do actually adhere to the CQRS theory, which is not just that you have one model, but the idea that you can have many query models. And this is one of the main tenets, and why we have a persistent queue is that we want to support APIs, complex query APIs that we don't know about yet, but we know we're going to need to be able to expose. So one of the key reasons we've got for this is that later on we will be able to reconsume the entire queue into a new database with a bespoke shape for new API requirements that are coming down the pipeline. That said, what would we do differently? Probably start a bit smaller. Actually, that kixi comms module helps a lot with this because we developed a lot of the system just using core async instead of Kafka, and then we swapped it out. That works really well because it allows you to prove some features of your system. And actually, doing that, I was able to throw out loads of things that people thought were requirements. And when we showed it to them, there was no interest. They realized it wasn't worth doing. It's very tempting in the name of having a solid foundation to do this sort of stuff. But what you end up with is what we have now, really, which is a massive skyscraper scale foundations, but there's actually just a small hut on top of it. Now we're hoping that we're going to build out the rest of the skyscraper, but if that doesn't happen, it's going to feel a bit stupid. So start small, prove your way out. Don't be too strict. Just because you're using CQRS or you think you are, not everything has to do it. So we rolled back some stuff out of the command pattern into normal synchronous commands recently, just because it made sense to do that. So just because you've got a pattern like this or you think you're using it, you can still change your mind on a case-by-case basis, and I definitely recommend you do that. It's always a balance. And yeah, beware of complexity breeding complexity. So this is very complex. It is a lot of incidental complexity. You can get carried away with developing complex solutions to simple problems when you have this kind of power at your hand. That said, it is good to be prepared. 2.5 minutes over. Thank you very much for listening. These are the 3 main people who've been developing it: myself, Anthony Woods, and Elise Huard. It's all at MastodonC. All the projects start with Kixi. That's it.
Thank you, Tom. Thanks, everyone.